Alrighty, welcome to Emily's review session, as Emily is our question asker of the day. Um, alright, let's just get to it, I guess. So first let's do number 25F, it looks like. I have these printed out here. Alright, 25F asks us to balance something with basic solution as well as to identify the oxidizing and reducing agents. So we have our equation. We have that plus hypochlorite turning into lead 4 oxide plus Cl minus. Okay, so, and it's telling us we also want to do this in basic solution. So first step first, let's identify our half reactions going on here. So we're going to see that one of them is going to be turning the lead, oxidizing the lead. Oh, I guess I shouldn't have said that. And then we're going to, I guess, reduce the other one, right? So if we know that this one is oxidation, so we have lead in the plus 2 oxidation state here. Here it's plus 4. From chlorine, we have it going plus 1 to minus 1. So this is going to be oxidized or oxidation reaction. This one is our reduction. And we're going to be, because the lead is going to be the oxidation one, that's going to be our reducing agent. And then the hypochlorite would be our oxidizing agent. So at least that part we're done with. So, but still got to do all the balancing and stuff. So let's go ahead and start with the lead one. So remember, when we are balancing in basic solution, we just want to start by balancing it in acidic solution, and then we'll just try to change it at the end. Good morning, Lovepreet. Looking at that, first things first, we want to balance our lead. Already done. So next we want to balance oxygens. It looks like we have 4 on the left, 2 on the right. So let's add a couple of waters to the right side. Next we want to balance hydrogen. We have 4 on the left, 4 on the right. We're okay with hydrogen. And the last thing we need to do is to balance out the electrons. And so we're going to do that by adding 2 electrons to the right side. We need to do that because we have 2 negative on our reactants. We need to have, therefore, 2 negative on our products. Thankfully, because we didn't have any hydrogen ions here, we don't have to worry about changing those to hydroxides, so we're okay. That one is already balanced in basic solution. If we do the other one, we start by balancing chlorine. Chlorine's already balanced. So now we need to add a water to balance the oxygen. And we're going to need to put 2 H pluses to balance that side. And then 2 electrons to balance the charge. Since that's how we would do it in acidic solution. But since it's basic solution, we're going to add 2 hydroxides to both sides. Remember that this is going to actually make 2 waters. So that water is going to go away, and we're going to just have 1 water left once we just subtract 1 water from both sides. And so if we rewrite this, we're going to get Cl minus plus 2 hydroxides. Alright, so now we can go ahead and combine the two. So let's go ahead and take our previous reaction. Here it is. They both have 2 electrons going on. Oop. Because I didn't copy it after all. Alrighty. So with that, when we add them up, we're going to see the electrons will cancel out. One of the waters will cancel out here, and everything else is going to stay. So we can go ahead and now just combine these. Turns into chloride plus 2 hydroxides plus lead oxide plus water. And of course, we'll have all of our state symbols like before. Nothing's different. Water will be liquid, the lead oxide is solid, everything else is aqueous. And we've done it. Hooray! So that's how we would balance that one. All right, so hopefully that makes a bit more sense. Alrighty, next one is 30HB. Let's see, this is, nope, not on that page. Here it is. Okay, 38D. We are going to calculate standard EMF for the following reactions. Okay, so we have chlorate, plus some bromides, plus 12H plus, turns into Cl2, plus Br2, plus 6 waters. Okay, let's look at this reaction, see if we can't identify the half reactions that are taking place here. Hopefully we can see that one of them is this reaction, and then the other one, our oxidation reaction, is the oxidation of bromine to bromine. The waters and H plus there are just there for balancing purposes, so those are not actually going to be doing any redox stuff. Chlorine and bromine are the ones changing. So what we're going to want to do is go to our handy dandy Wikipedia page. We probably have the hydrogens and waters involved in this first reaction, but those are kind of just secondary. We don't really have to worry about them, but we might see them when we're looking up our EMFs. Those might be part of it. So let's go ahead and look up the electromagnetic forces for these. Oh, by the way, so we know that this is the oxidation, this is the reduction, right, that's happening here. Let's go ahead and look them up. So if we look up, oh gosh, there's so many chlorines in this. All right, where's chlorate going to Cl2? Okay, that one, I found it, it looks like it's a voltage of plus 1.49 volts. And then let's look up bromines. So indeed, that does have the hydrogens and the waters in there as well. The other bromine is bromide going to bromine. So let's keep searching there. Are we dealing with aqueous or our bromine is liquid? Okay, so we're going to be dealing with the plus 1.066. All right, so remembering that we want to do, remember that the cell potential is the reduction potential minus the oxidation reaction that's happening, or if you want to think about it, the cathode minus the anode. So that'll be 1.49 minus 1.066, which is equal to, I need Kevin to do this calculation for me, plus 0.424, so 0.42. I think that seems about pretty reasonable, and so that is our potential for this cell overall. What do you mean 0? No potential? Get out of here. You probably just pressed enter too quickly. Okay, yeah, 424, but since the 1.49 just had the 2 decimal points, we'll keep it as this. Cool. Alrighty. So I think, yeah, the hard part there is kind of figuring out what the heck to do with these guys. You can kind of ignore them, but we did see in the, if you look in the reduction table, you find the chlorate to chlorine. You do see that those H pluses and waters are present in that half reaction. So I've just kind of simplified it just to make it easier for me to find it on the table. So you don't have to worry about those unless those are part of the redox chemistry, but they're not because it's H plus going to water. So there's no change. All right, and let's go ahead and see what the last problem was. 40A. Okay. Any questions on those, by the way? 40A, right? The combination that leads to the largest EMF. Okay. Alrighty, so if we want to do this, I'm just going to write down the cell potentials that we have here. Actually, I guess I should write the reactions, fine. Okay. ABr4 plus 3 electrons turns into gold plus 4 bromides rather. And then we've got the potential here is 0.86, negative 0.86. We have europium plus E minus turns into europium 2 plus. Potential for that, negative 0.43. And then the last one we have hypoiodite plus water plus 2 electrons turns into iodine plus 2 hydroxides. And we have a positive voltage there. So, we're asked to combine two reactions such that we're going to get the kind of best overall potential by combining these, the highest potential. If we want our highest potential, remember that we want, it's always reduction minus oxidation. So only one of these reduction potentials is positive. So that's one we should use as our reduction potential. So I would suggest that we go ahead and use this as our reduction. And we just have to figure out which oxidation then we want to do by flipping this, the signs around. So notice though that this is a 2 electron process, whereas the top reaction is 3 and the bottom reaction there is 1 electron. So if we want to put these together, we have two ways. We can combine the iodide oxidation, hypoiodide oxidation into the europium one or to the gold one. So if we do that, we're going to see that if we do use the europium one, we're going to need to double that reaction so that it would have 2 electrons. We would get a voltage of negative 0.86. Remember that this is going to be minus the oxidation potential, so that's going to end up being a positive 0.86. So if we use this reaction, we get plus 0.86 by doing that. However, if we use the gold reaction, remember that we're going to want to make them have the same number of electrons, so we're going to need to double the gold one while also tripling the hypoiodite one. So sorry, let me back up a little bit here. If we're going to couple the second two reactions, if we do the iodite plus the opposite of this one, if we do this reaction, we're going to end up with which will be 0.49 minus negative 0.86, which will be positive something, 135. That doesn't seem right. 4 plus, no, it is right, okay. If we couple the other one though, if we take this one plus the gold reaction, this time we're going to need 3 times our reduction potential minus 2 times our oxidation potential. And so that'll be 3 times 0.49 minus 2 times negative 0.86. That's true. Electromagnetic force is a state function. You're right. Why am I doubling these? You're absolutely right, Kevin. I think I'm too much in the free energy land in my mind. All right. So if we do this, uh, we're just going to have the negative 0.43, and so we will end up with, Kevin, please calculate, 92.92. If we use this one, again, we're going to want to do our reduction potential minus our oxidation potential. Yeah, don't listen to me. I was too much in thermodynamics. Where is that? 0.86. Okay, so we have 0.49 minus negative 0.86. That'll give us a higher cell potential. And so this one will be the plus 1.35. So that's the higher potential there. So if we do want to combine these reactions, though, that's when we're going to have to balance them correctly. So indeed, we do not need to multiply your E by the number of electrons. That's absolutely true. All right, so if we're going to do that, we're going to reverse that first reaction, and we're going to keep the other one the same, but we are going to now multiply them by 2 and 3 respectively. So if we take our bottom one, our iodite, and multiply it by 3, let me just copy it again, plus 6 electrons, turns into 3 iodides plus 6 hydroxides. And if we double the reverse of the first reaction, two AuBr4 minus and 6 electrons. So let's see what cancels out. Should just be the electrons, I think. Yeah, everything else will stay the same. So if we combine these, we're going to get 3 of our hypoiodites plus 3 waters plus 2 gold plus 8 bromides turns into 3 iodides plus 6 hydroxides plus 2 of that gold tetraboride ion there, and of course with the appropriate state symbols. All right, and so that would be the combined reaction that's going to give us the best overall potential. And so we can go from there. All right, so hopefully the second part of that is, just note that the second part of this question asks for smallest positive. So it's still going to be positive when you're doing the next problem. So just keep that in mind. So don't make it negative. Alrighty, cool. Thank you, Kevin, for catching me on that. Hopefully everything else is okay. Alrighty, so those were the 3 questions that we have. If any questions do come up, yeah. So in this case, we just did the math here. We tested both of them. Obviously, the 0.49 is going to be the one that will start us off the right way, because if we started with either of the others as reductions, they would be negative. So we want to start with the most positive as our reduction potential, and then we're going to use the most negative as our oxidation potential. You'll probably see that if you combine the other two, you'll end up with 0.06, right? So that's probably going to be your other reaction. But wait, no. That's not going to be the case. I don't know how to add. Never mind. Don't listen to me. I'm crazy. For the other one, you'll have to kind of try combining them together as well to see what you'll get by doing so. And so the second one's the smallest, right? So, yep, cool, awesome. Alrighty. Well, if that's it, If other questions do come up, write them in Discord. I'll type my answers to you guys. Or if I need to like scribble it out, I can go ahead and do that and upload the file as well. If it's too hard for me to just type out. So, all right, I will upload these, and we will. I guess I could just. Well, Kevin's here. I don't know if Athena's here. We can just do our honor stuff now. Okay. Well, that's there. Hopefully, the video will behave. So your other video is still marked as broadcasting because it's crazy, but oh well. All right. Well, if that's it, well, good luck on your exam. I'll see you Tuesday. Other questions, type them out. We'll get through them. All right. Enjoy your weekends.